In this lesson, we'll discuss the analytics of solar panel marketing case. First, we'll briefly introduce the case, then we'll provide data and variable descriptions, and lastly, we'll discuss and implement the relevant set of questions and make inferences. In this video, we'll introduce our solar panel marketing case study. Your company sells energy efficient solar panels. You have divided the country into 100 sales zones with codes and one sales representative in each of the locations. So you have sales reps in each of the location and your sales representatives are profiled by gender, professional experience, engineering degree. We have these variable descriptions shortly coming. Then around 50% of the sales rep have at least 5 years of professional experience in sale and 1/3 of them have an engineering degree. That is what your company claims to show the expertise, and the prices differ across geographical territories, although the cost is 2 lakh rupees per panel. The variables given in data, as we'll see when we are implementing the case, is as follows. First, you have a quantity variable, which means number of panels sold, the price in thousands, you have experience of the sales rep in terms of relevant years of experience as sales representatives, engineering degree, whether the sales rep has engineering degree, if yes, then 1, otherwise 0. Then you have gender, so if it is a female candidate, then 1, otherwise 0. If you have the sales representative from the native state, whatever its native state is coded in numbers. So for each state you have a particular code, and if the sales rep comes from that native state, the code will be assigned. Then you have agency budget. So whatever total marketing budget is given to the marketing agency or advertising agency, that is mentioned in hundreds. It can be in two form, either telecalling, telemarketing, or social media marketing. So you have this budget phone variable, which represents that telecalling, telemarketing budget in hundreds, and social media budget again in hundreds, which is the budget spent in social media marketing. Welcome to all. We have already discussed the case study and introduced it. Let us start the implementation of this case. As a first step, we'll set the working directory and load the packages and data. As a best practice, I tend to first set the working directory correctly for the session. This is done by going to set working directory, choose directory, go to the place where your data is, click on it. It is better to just copy this link so that you have this for future reference. You don't have to remember the location. Now, if I have done it correctly, you would notice that the sales underscore data, which I'm going to use in this case study, is appearing here. The next step is to download the relevant libraries for the current working environment. So in this session, I'm going to use Stargazer package. Stargazer is very important for printing the output in a very nice fashion. We'll see that. Second, we'll also use a very important package, Tidyverse, which is an advanced package for data analytics in R. So now that we have run our packages, we have loaded them in the current working directory, we are good to start with reading the data. So all you need to do is go to this sales data, import dataset. And once you do it, one package is getting installed. It may not necessarily, if you have already installed it, it may not. And you can see the data has appeared on my screen. I can see the columns, I can see their values. If I click on import, notice a command line has appeared, which shows me that one particular package, readxl, was installed. If it was already installed, it would not have been the case, but it was installed for the first time. So it got installed and added through this library command. You can see a view section also. A view has appeared of the data, though it's not very important here now. I'll also copy paste this command so that I don't have to sort of write this code in future. I'll just keep writing these commands here. Now, if I've read the data correctly, let's run through a few simple commands. First and foremost, a glimpse command is a very useful command which I can put in my sales data. And you can see here the variable description that we saw earlier in the discussion about the case study. Similar variables are appearing here. For example, we have a quantity variable, price, experience, engineer, gender, location, budget, agency, and so on. You notice some of the variable, for example, gender is in numerical form like 10. We have to convert into categorical or what we call as factor variable in R. Similarly, our engineer variable is character variable, which we also have to convert at later point of time into categorical variable in R. In fact, let us convert them right away. So I'll create another sales underscore data dollar gender variable, which is nothing but the factor version of this original data. So this will be now converted into gender. Now, whether it is converted correctly or not, I can simply just do a summary of it. And you notice now the summary would not be in the numerical form, but more in a categorical form. So it tells me that there are 100 values of one. Later on, it's although we have jumped the gun, but later on we'll see that there's only one gender in data. That is why this is happening, but we'll keep on that for some later point of time. Similarly, we'll convert this engineer variable also into factor. Let's see how to do it. So I'll create another variable which is ng engineer, and this is a new variable, and the old variable will be used to convert into factor. Now if I've done it correctly, as again we'll repeat that same summary and see what has happened to our newly created variable. We should be able to see appropriate summary here. I've just increased the size a little bit, font size. So you can see here, no, yes, now they are treated as categorical variable, not as numerical variable. If you want to see the contrast, I'll summarize the engineer variable also, the older one, the one which is in the character form. And notice something interesting. So if I do that, you can see that it is not very appropriate summary in the character form. So to summarize this video, in this video, we have set the working directory, added the required packages to our library, loaded the data, and see if we have read the data correctly and converted some of the relevant variable into categorical from numerical and character variables. In the next video, we'll start with the data exploratory part. In this video, we'll discuss part A of the case study, which is exploratory data exercise. In the exploratory data exercise, we will first examine the gender-wise breakup of the sales rep. In the second part, we'll see the distribution of prices across territories. In the third part, we'll check the distribution of sales rep experience. For example, the company is claiming that 50% of the sales rep have at least 5 years of experience, whether it is true or and what is the breakup of that. Next, we'll see what is the professional background of sales rep. For example, the company claims that 1/3 of them have an engineering degree. We'll test the veracity of this claim. Next, we'll check whether the advertising agency's budget differs across sales territories. That we'll check. And then, did the advertising agency achieve the aim of approximately equally allocating the budget to two channels? So there are two channels, telecalling, telemarketing, and social media marketing. So if the company is allocating them equally, and more importantly, if there is a need for higher budget, whether it is distributed in same proportion, it should not be higher in one, too much lower in other, and so on. Lastly, are the sales rep coming from sufficiently diverse places? So these are the questions we'll examine as a part of exploratory data analysis. In this video, we'll start with the second part, part B of the case. In part B, we'll do exploratory data analysis. As a first step, we would like to answer the question, what is the gender-wise breakup of the sales representative? What is the gender-wise breakup of sales rep? Now, a very simple command is needed. All we'll do is we'll just run this command. We have already categorized our gender variable into factors, so we need not do it again. We simply type gender. If I write it like this, slightly not so sure, so I'll just put a summary command like I did earlier, and inside summary I'll put this gender variable. Notice this command tells me that there is one category and it has 100 values. Now suppose there were two genders, then you would have data in the form of ones and zeros. Now because in our data all the genders, all the candidates are female only, so it shows that only one gender with 100 values. And total also, if you want to see the dimension of the data, this dim command shows me the dimension, which shows me that there are 100 values. So all the 100 of them are female. The next step is to visualize also. You could have visualized, although in this case it's not very helpful because there's only one gender. But still, if you want to visualize, let me show you how to visualize the data with the ggplot. It would have been more meaningful when there were two genders, at least more than one. So then, but you can't do it here. So ggplot sales data AES. Now I'll put the gender variable here, and so in ggplot, first you specify the variable, then aesthetics. Inside aesthetics, let's say it's XY diagram. So you want to specify what is the XY axis. I'm specifying only one variable, so it knows that it has to be only one dimensional plot. In the sense, only one variable is to be plotted. Now, what kind of geometric object we want for such 1D plots? Although it will be 2D, but in the sense that there's only one variable, you would want bar objects. That makes more sense. And in the bar, I would like to fill it. The color should be gender. So suppose there would have been more genders, you would have found. Let me show you. So you can see there's only one color. But supposing that there were more sort of genders, you would have found more colors here, each gender with a separate color. But that is not the case here. Now, as part of the next question, we are supposed to see the distribution of prices across territories. So we want to answer the question, what is the distribution of prices across categories? Now, this is also a simple question, but can be answered in multiple ways. So one starting point would be just to check the summary. And if I run the summary command and apply the price, so we can see the price varies from 209.4 to 369.4, which means there's a lot of variation across locations. Then you have another way to do this thing is to visualize the data. So let's visualize the data. So for that, you need to run this ggplot command. And in ggplot command, we again specify our object, which is sales data. Then AES is price. So we want to visualize the price data. Then you need to specify the object. So let's suppose I want to specify histogram. Histogram seems to be a very appropriate case for this. So histogram I'll use. All you need to do is geom underscore histogram. So you'll get a histogram here. Now if let's say I want to fill with blue color, so this will be the fill of the bars inside the histogram, and outline would be red. So red color would be the outline edges of the bars or square shaped bars there. So I specified that. Now let's say, let me plot this and let me show you something more can be done here. So let's say I plot this, it would be a decent looking plot. So if I run this command, you notice a nice plot has appeared with blue bars and edges are red. It's slightly overdoing things, but still you know that something can be done. And you can see the distribution. For example, you can see most of the prices are around this 300 range. So most of the sort of prices in this range across the territories, particularly the lower like 200 and 350 plus is much less. So you know what is the distribution of your pricing variable. And if something needs to be done, particularly on the higher extreme price and low price, and maybe you're losing out on customers with these high prices, or probably you are making losses on these low prices, you may want to do something about it. Now, although it is over doing something, but I would also like to add some labs here to give some nice names. So title equal to histogram of price, then y equal to number of sales territories, and x equal to price. So this would sort the naming thing out, and let me show the outputs. You can see now the naming convention x, y axis are very nicely named. So this is how this can be done. In addition, you would also like to see the distribution of data through a very interesting plot called box plot. So once you have done the histogram, you have some idea, but still you like to see more. I'll reuse the same plot. I'll not sort of rewrite the code. I'll just copy paste it. All I need to do, and this is the power of ggplot, the first layer remains the same. Only the second layer, I want a different geometric object, which is box plot. So all I need to do is first specify that it's a box plot, one, and then maybe I'll change the color just for the effect of it, green. That's it. It's just a stupid change, nothing else. Now here, instead of histogram, because I'm making a box plot, I'll put it box plot of price. And also in this case, probably I would like to make it y-axis. For I like the box plot upside down. You'll see the effect of putting it that way. So you'll see a vertical kind of box plot. Let me show you, and then we'll interpret that also. So you can see it's a vertical kind of box plot. Now, if I would have put it X here, then you would have got it horizontal. Let's interpret it. The way to interpret this box plot is that it shows you the distribution of data. So it tells me that my observations scatters from this almost 200 to 350, somewhat, and the box contains the median line. At the mid of this, there is a median line. So 300 is the median of the data. Now you will find here are approximately 375 and 325, the upper and lower edges. These upper and lower edges of this rectangular is sort of 25 and 75 percentile. So we know what is percentile. It's like approximately 25% observations are less than whatever this number 275 is, and similarly 75% are less than maybe this 325 or something. Also, the difference between this upper and lower length is called interquartile range. So this 75 percentile minus 25 percentile is called interquartile range. This is further extended 1.5 times the IQR, interquartile range. This IQR, this upper edge is extended further. This is called whisker. Similarly, the lower edge is also extended below 1.5 times IQR. And this becomes your Vox plot. Anything above here, there are no other anything beyond these whiskers. But if there are something in whiskers, then plot they appear as scatter points. In this plot, there is no scatter point, so we are safe. These scatter points would have represented the extreme outliers, which is not there. So to summarize this video, we started with the exploratory data analysis. We examined the gender-wise breakup of the data, found that there was only female variable. Then we also examined the distribution of prices through summarization of the data, and also we visualized the data through box plot and histogram. In this video, we'll continue with our exploratory data analysis. Recall that at the beginning, the company stated that 50% of their sales rep have at least 5 years of professional experience, have 5 years of professional experience. So we would like to know what is the distribution of sales rep experience. Maybe it is an important variable. And later on, what you'll see as demand function. So it may be an important variable. So a very simple way to do that is to look at the summary measure. So I can write summary, and then because I'm looking at experience, I can simply write this experience variable, and I can see it starts from 0 up to 10. So that's 10 years. 0 to 10 years. So there's quite a lot of variety. But if you want to see more in a tabular frequency manner, so you'll see what I mean by tabular frequency. So this table thing would give me a more clear picture. See, there are 10 values, 0 to 10, but now we can see 0 year of experience, 2 candidates, 1 year of experience, 9 candidates. It's more heavily loaded initial 5 years, and then the experience declines. We would also like to see whether the claim is indeed true. That means 50% have more than 5 years of experience or not. So for that, a very simple way would be to sum the sales experience. And now a very interesting line of command I'll use. I'll put it greater than equal to 5, which means it will generate false in case it is less than 5, and 1 in case it is greater than 5, true, which means, for example, if I run this only this line of command, you'll see trues and falses. Now this sum will add the trues and falses. For R, these trues are 1 and falses are 0. So if you add up, you'll find 38. And we already know that 100 data points are there. So you know it's 30%, but still a better way would be to make it more dynamic so that if new data comes, you don't have to change the command. So we are not actually putting 100. We already knew it's 100, but still we'll use a more dynamic approach. We'll write the code itself. Dim sales data. Now if I put 1 here, it will take the first element. So this dim data gives me the rows and columns. So you have 100 rows and 11 columns. With this square bracket index 1, it will pick up this 100. Now if I divide it, I'll get a 0.38, which is like 38%. So approximately 38% are the ones. 38% have more experience, which is not as claimed by the company. I would also like to visualize my data. So one simple way would be to use bar plot. Let me show you. So I can visualize through bar. Let's see how. So I'll use this ggplot, sales data. Now I need to sort of use aesthetics. And in this case, I want to only visualize one object, which is experience, and more in factor form. I don't want a numerical kind of variable of experience. I want a factor kind of approach. Otherwise, numerical summary would look slightly stupid. So this one. Now in this, you want a bar plot. So you tell R that I have a variable experience which I want to plot, and I want a bar plot. A few argument, maybe you want a fill to be blue like we did earlier. You can change it. There's nothing sort of rule that has to be blue, and the edges to be red, which is again of your choice. So you can use this. Now, if I plot it, plot it, I get a nice shaped curve where I can see now more correctly, like similar thing we saw in the table, that you have nice distributions from 2 to 5. You have a lot of people, 2 to 5 years, but beyond 6, 8, 9, 10, probably these are the in the leadership roles. They have a slightly less experience, so something to that effect. Now, as we did earlier, you can also add labs if you want to make it more publication quality graph. In like in my research papers, I tend to make it do it like this. So you have title, box plot of experience. On y-axis we have experience. This is just to tell you that you can sort of do something like this to make your graph more publishable. And now you have a nice clean graph here. In addition, if you wanted, you could have sort of got the box plot also. This is the bar plot. So you can add bar plot instead of that box plot, which we interpreted earlier also. So here I'll just simply use change this, and this is the power of ggplot. I don't have to sort of modify my code to a great bit. Some changes are not, though not necessarily needed. I'm just changing the color here, and here, oh, it should have been bar. So it was earlier, it should have been bar plot. Now it is box plot. And now if I plot it, you will find a nice box plot here. So all I need to do is I need to remove this factor thing, and now it should do justice. Because see, box plot is more of a numerical summary. So if I apply factor thing here, it would not give me a good idea of this thing. So box plot is more for a numerical summary, and like earlier we made a mistake when we use here as a factor. See, it is a horizontal one, and let me make vertical. So let's see if it works. Yes, now it's better. And now you can see there are two outliers. You can see there are two outliers. So if I run it, you can see there are two outliers. Now these two outliers suggest that they are beyond those whiskers. That means they are beyond the box interquartile range. That is whiskers adding on the top and bottom. When you add those interquartile 1.5 times IQR interquartile ranges, you get those whiskers. These 2 points on the top are beyond, further beyond. That means they are purely outliers. Probably in organizations at leadership roles like CEOs and CFOs, they would tend to be outliers in terms of the experience. So maybe on that account. So to summarize this video, we continued with our part B on the exploration of data, exploratory data analysis. In this particular section, we visualized the experience of sales. In this video, we'll continue with our exploratory data analysis exercise. The next question is, what is the professional background of the sales rep? Now, if you recall, the company made a claim that approximately 1/3 of the sales rep had engineering degree. So let's test this claim. A very simple command, we can run this table command, and this will, with factor, will specify the degree as factor. So engineers as factor, recall. It can be more appropriately summarized. And then when we apply table, we can see that 72% of them are not engineer, only 28% are the engineer. So we can say that, for example, this claim that 1/3, it's slightly less than that. It's 28% only. We can visualize this also. Now you notice the visualization with ggplot would be very effective. So as we do layer by layer, first we'll specify the data that we want to plot. Next, we want to plot our engineer variable. Then we need this plot to be a bar plot. So I'll specify it to be a bar plot, and then fill to be engineer. So if it is engineer, there'll be one color. If it is not, there'll be another color. Now let me run this. So this has to be an aesthetic because we are putting colors as aesthetic. So we'll fill it. Now you can see a very nice plot where you have engineers, non-engineers. The same data that we had this table printed here 7228, which is more in a more graphical sort of form. So it's more explicit. Now, if you want to improve this plot as we do, we would like to add some title, which is bar plot of degree. We would also like to add the y-axis label, which is number of sales territory, and then x-axis will keep maybe empty. Also, you notice that on the legend, the engineer is not very properly written. So probably if you use this fill argument here and write engineer properly in caps, you would notice it will change. And a very nice plot has occurred. So you can zoom it out and you can see it. So to quickly summarize this video, we explored the question in this particular video, that whether what percentage or what is the distribution of degrees engineers versus non-engineers as sales reps, and we saw that approximately 28% of them are engineers. Let us continue with our exploratory exercise. In this video, we'll examine whether advertising agency budget differs across the sales territories. So does the advertising agency budget differ across the sales territories? Now, to answer this question, the first thing one can do is summarize the data. So let's summarize the sales data for budget agency. Now, you would notice there's a considerable difference, 329 and 2056 lowered to higher. This, of course, depends upon the territory to territory. Some territories may have more potential where the company would like to put a higher budget. Let us visualize this also. And one obvious candidate is the histogram. So if we visualize this through histogram, we can apply this ggplot. Again, first layer would be the data layer. In the data layer, we need to specify what object we want to specify or visualize, which is budget agency. Now we only want to visualize one object, so it's like a one variable plot. So some of the obvious candidates would be like histogram would be one way. So let's plot the histogram of data. Now, like we did earlier, we can give some fill, maybe green, and fill would be the color inside bar, and the edges would be with this color red, maybe. It looks good. Let's run this. So you can see the bar and the count. Now the last step would be to improve the plot. So let us put the access labels and other things. So titles. So first is the title, which is histogram of budget agency. So histogram of budget agency. This is the title of the plot. Next thing I want to give is the number of sales territories, and last thing is equal to price. So now we are done. So you can see a very nice plot has appeared. You can see the prices. You can see most of the prices are scattered in this range of 1,000, somewhere around that. The lower ranges are around 500. It's worthwhile to examine whether these lower budgets are in appropriately small territories, while these higher extreme budgets, which is some is 2,000 and this thing, can it be reduced? Is it justified in those localities? That would be the right set of questions the firm may want to ask. So to summarize, in this video, we analyze the distribution of budget of the marketing agency. So we'll continue with our exploratory data analysis. And in this video, we'll try to answer the question whether the advertising agency distributed their budget equally within the telecalling and social media marketing. So did the advertising agency equally distributed the budget across the two channels? Now, it may not necessarily be equal, it can be any proportion. It's just we want to test or we want to compare the proportions. So across telecalling and social media marketing. Let's try to answer this question. A very simple and obvious way to answer this question would be to check correlation between them. So if we compute this correlation, this your command will simply give us the correlation. Why we are computing the correlation, I'll explain. So one is budget in social media and other is budget on phone. So if I run the correlation, you would see it's very high. It's almost 99%. So this is a good sign which shows that whether a given locality or territory requires a higher budget, it increases for both the channels. And if it requires lower budget, it decreases. So both of them go together hand in hand, which is right. It shouldn't happen that if a territory requires low budget, one particular channel has a higher budget and other has a lower, which doesn't look good. So a positive correlation with such a high looks good. Let's, as a next step, you'd like to visualize the data. So simply you can add this ggplot command. Same exercise will repeat. Sales data. Now, in this particular case, we would like to visualize the budget, and there are two aspects to it. One is budget, social media budget, but we would like to compare it with another data, which is budget phone, telemarketing budget. Now, so therefore we have two variable kind of plot we need, two variable plot kind of, we need XY kind of plot, what we say. So we have specified that, and therefore if I run this, you notice that now two axis XY kind of plot is appeared. Earlier there was to be only one axis X or Y on data axis, but now we have XY axis kind of plot. But now we need to tell us more detail, like what kind of objects we want to plot and so on. So let's start with a very simple scatter plot, for which you need to give, because scatter plot is a plot of points, you need to just mention point. So this will give you the scatter plot. Now I would want a little bit aesthetics here, so maybe red color dots would be okay. So we are doing this. You need not do it. It will be then empty kind of solid dots, maybe dark colored black dots. So then you have geom smooth. But this smooth will plot some kind of smoother according to a particular scheme. You can follow different schemes. For example, let's say I put a color of, I'll change the color to blue because already red we have given for this thing. But now I need to specify what kind of plotting I want. So I'll use, and we have already seen regression plotting with LM object. This LM object will ensure it's a linear straight line kind of plot which need. So let's see what kind of plot has appeared. Now plot is like almost sort of straight 45-degree kind of line, which tells us that there's a very strong 50-50 kind of relationship between both phone and telecalling and social media budgets. Let's add some axis here. So title, I can add scatter plot of budgets, and Y is telephone. So now Y we have telephone, so I'll write it as telephone, but it is in thousands. So I need to put 3 zeros, thousands. Now, x-axis is also important here, which is social media, and it is also in thousands. So that's it. So let us see how it looks. Now it's a proper publishable plot. We can see that's a very strong correlation, 50-50. But we need more than this visualization. We need some statistical inferencing. We need some more statistical result to be sure of. So one obvious candidate is t-test. T-test is a test of mean comparison. It gives you sort of on average whether the data is significantly different, both the data are significantly different or not. So for example, I need not retype it. I'll just copy it from here. So I'll compare two data points. One is the social media budget, this one, and telecalling budget. And with this t-test, it compares their means. So the mean of X is 513.92 and Y is 514.27. If you have been following this course, recall we did something called statistical inferencing. Here we are comparing these two means for their statistically significant difference or not. So we can see here the p-value is almost very high, like 0.98. It means the difference is not very significant. Look at the alternate hypothesis. Two difference in the mean is not equal to 0. We are not able to reject the null, which means we are concluding that two difference in the mean is equal to 0. So almost 50-50 distribution is there, we can say here. If you want more surety, it is also called Wilcoxon test. The logic here is that the mean or average differences that we checked earlier often get vitiated by extreme observations, whether on the left or right. So you'd want some measure like median, which is not vitiated by extreme positive or negative outliers. So we also compare through this test of median. Basically, it's a test of location, which is represented by the median. So test of location scale shift. So let's run this. Now, again, this result also, the see here, we have the p-value and corresponding W statistic, Wilcoxon statistic, and we have alternate hypothesis, true scale shift not equal to 0. Now, please note the p, given the p-value so high, we are failing to reject the null, which means true location shift is equal to 0, or the median of both the data is same, and therefore we can say that 50-50 distribution between these two budgets is there. To summarize, in this video, we compared the budgets allocated to social media and telecalling. With this video, we'll conclude our exploratory data analysis exercise. So in this video, we'll answer the question whether sales rep are coming from sufficiently diverse places. are the sales rep coming from sufficient diverse places. If you recall in our original data, one variable location mentioned their native place with the state code. So for example, if you want to check in a very basic manner, you can just simply factorize it, put it as a category variable and use the location. So you'll notice that all the levels are mentioned. So there are 3, 3, 6, 9, 11 levels are provided. So we have 11 levels, but also it's sort of, you can see different values are there. So one way to sort of simply summarize data would be to use this table variable where I can type sales data dollar location. Let's see what this is. This would sort of in a tabular manner, you can see for each location 7, 8, 9, 10, 11, so on. You can find for each of the codes, you can find the frequency. For example, 7 has 8 people, particularly the location 19 has 3 people, and so on. So that is sort of code frequency. Now you'd also like to visualize the data, and to visualize the data, one simple approach would be to use this ggplot command. And like we do, first we probably would like to see a bar plot, and we'll use one variable. We have one variable to be specified, which is we'll factorize it to get a better ball plot. So for this kind of thing in a location which we want to visualize, bar plot would be appropriate. And so we are factorizing it, putting it as a category, location as a category. So our bar plot is more appropriate. We'll use this geom underscore bar. Now again, fill maybe blue and color may be red. So this is a basic dimension that we have put. You can see the plot has appeared if I run this command, but we'll also sort of improve this a little bit with axis labels and so on. So we'll put the labels, labs command. Title is bar plot of location. We also want some name for y-axis, which is number of sales territories. And we also want x, maybe x as state code maybe. So now if I run it, you'll notice a very nice plot has appeared. I can zoom it for you. So if I zoom out it, you can see here, y-axis is number of territories, particularly territory number 10, 11, 12, 13. These are the highest one. In 7, 8, 9 states coded with 7, 8, 9 and 16, 19, lesser number of this thing. So you'd want to know whether these are larger states. So they are represented by a fair bit of reps, or these are smaller states, or these are very large states. That so ideally you would want, if a large state should be assigned a large number of sales reps and so on. In this video, we'll discuss the next three parts of the case study, parts B, C, and D. First, we'll estimate the demand function using a linear regression model. Now, here we'll assume that the quantity demanded as the dependent variable and price, experience, engineering degree, and budget, marketing budget as independent variables. And we'll examine the model, interpret the results, try to find which of these variables are important and useful. In part C, we'll like to estimate the elasticity of price and budget for the demand. Here, elasticity is defined as percentage change in demand for a percentage change in price if it is price elasticity, or agency budget if it is budget elasticity. Lastly, we'll also try to answer the question, what is the relative contribution to demand from budget allocation to telemarketing vis-a-vis social marketing? So if there is $1 spent on telemarketing budget or vis-a-vis social media marketing budget, what is the relative impact on the demand? In part C, we would like to estimate the demand function as variables that are price, experience, degree, budget, as a linear regression function. Now, this obviously should come from a priori by theory, whether you want to estimate a linear regression or what should be the right variables. But hypothetically, we have assumed here that these are the right set of variables. As a practice, when you're working with data science, you should do all permutation combination. For example, we have these four variables. We should try all the combinations. First, we can try them individually. Generally, you should start with individual modeling. So quantities are variable. This is our dependent variable. If you recall the syntax, then first regressor is price. So right now we are using only one regressor and we'll store the output in model 1. Then in model 2, And now I'll just keep on copy pasting the same code, just change the name of the independent variable. So next independent variable is experience. The third variable that I'm interested in, model 3. Which third variable is engineer, which is more of a categorical variable, degree of engineer or not. So engineer R has this power to automatically convert character variable into categorical variable. So we are good. Model 4. Now model 4 I want to run as regress as budget agency. Budget agency. Now you have run individually, you can run them in combinations, but in the interest of time, I'll not run them in combinations, but rather put them all in one go. So price, experience. So I'm putting them all in one go, but it's more advisable if you have time, you can sort of test them one by one. So you have more clean idea of what is happening in each of the relationships. Now I have all the models stored. I'll make use of this Stargazer package where I'll print all the output in a more systematic manner. We'll see how. So the way to do it is the syntax is use Stargazer. Stargazer. Now you need to put all the models, model 1, model 2, model 3, model 4, model 5. Also, you need to specify the type of output, for example, whether you want in HTML form. Right now, we want in text form. And it when you write text, it will be produced in the console window, as we'll see shortly. Header, maybe you choose header as true, so that you get the name of the header. You'll see what I mean here. So when I run this command, so now I'm running this. I have zoomed out a little. You can see the fonts are smaller so that my full output can be filled. You can see the output is generated now. So you can see here the output. Let's spend some time with this output. First, look at these R square values. Notice the R square value for the first model is very high, 95%, while others are small and in fact sometimes negative. For to some extent, this model 4 also has some explanatory power of approximately 5%. So first indication is that this price variable and this budget agency variable is significant. Now, this is also very clear from the t values. It has 99% significance, as we can see. So this coefficient minus 2.972 is 99% significant. Similarly, this is also budget agency is also significant, while this variable and this variable is significant here, but it is fluctuating a lot and its overall power is also not too large. So we would like to rather ignore this and take our focus into these two variables, price and agency budget in marketing. So these two seems to be very strong variables. Now, if you recall, the price variable was in thousands. So we can say that for each 1,000 rupee increase, the quantity of panels sold decreases by approximately 3 units. So each 1,000 rupee increase in the price of panel per unit, the quantity sold increases by 3 units. Similarly, let's come to the agency budget. Agency budget is in hundreds. So we can say that for each 100 rupee increase, the number of units sold increases by 0.08. Probably it will be more appropriate to multiply it by another 100. So we can say that approximately 10,000 rupees increase in budget agency would lead to 8 units increase in, because coefficient is 0.081. So we can say approximately, if we multiply it by 100, 8 units increase in the panels if we increase the budget by 10,000. So to summarize this video, we conducted linear regression analysis for demand function. We modeled demand as a linear function of price, experience, degree, budget, and we saw that price and budget came out as significant variables. In fact, price had an explanatory power of 95%, while budget has an explanatory power of 5%. We found that for each 1,000 increase, the number of units decreased by 3, and each 10,000 budget increase, the number of units increased by 8 units. In this video, we'll start with our part D of the exercise, where we'll estimate the elasticity of demand for price and budget. Now, please note, elasticity is defined simply as percentage. Let's say it is price elasticity. Then it is defined as percentage change in quantity for 1% change in price. Of course, it will be negative because when price will be increased, quantity will decline. Similarly, budget elasticity will be percentage change in quantity demanded for 1% change in budget. Now, a simple trick rather than going into complex mathematics of it, a simple trick is to use log-log kind of model. In log-log model, the interpretation of coefficient changes to changes in percentage. For example, if I run the model like this, model equal to LM for linear modeling, log of quantity is regressed on log of price, not the raw price, but log of price. In fact, this log is natural log, and the logs are very useful in accounting for heterogeneity. So if your data has heterogeneity problem, as we discussed in regression module, this log is a very useful approach. Now I'm putting this budget underscore agency, and I'll define data as sales data. Now, if I omit one of the variables, then the effect, let's say if I omit log price, then a lot of effect of this log price may be loaded on this. So it may result in incorrect estimation. If you recall in the previous regression models, we saw almost 95% is explained by price. That is the quantity variation, almost 95% is explained by price, and almost 4 to 5% is explained by budget. So it is important to keep both the variables in the regression. They are important variables. So we'll run the model and we'll summarize the output. So when I summarize this output, you notice the coefficient of prices, log prices minus 2.26. So the elasticity, so price elasticity is minus 2.26, which means quantity demanded declines by 2.26% for each 1% increase in price. Similarly, here the elasticity of budget is a coefficient of 0.11, or let's say 0.12 in more appropriate terms, which means that the quantity demanded increases, and obviously we would anticipate it to increase because it's, and therefore the positive coefficient increases by 0.12% for a 1% increase in budget. So just to summarize, in this video, we defined and estimated the elasticity of demand for price changes, which was minus 2.26, which means for each percentage increase in price, quantity demanded declined by 2.26%. Similarly, we computed budget elasticity, which was 0.2, which means 1% increase in price in budget, 1% increase in budget, quantity demanded increase by 0.12%. We also highlighted the log approach to simplify the calculation of elasticities. Coming to the last part of this exercise, in this video, we'll answer the final question, which is part E, where management wants to know the contribution, the relative contribution in demand from budget allocation to telemarketing versus social media marketing. So they want to know the relative or sort of marginal impact, which is more effective. Recall earlier we checked, they are 50-50% they are allocating more budget. And suppose they find that one particular channel is more effective, they would like to increase their budget there. So what we'll do is we'll separately run. And please note, there's a very high correlation between these variables. So we would like to run them separately because there'll be multicollinearity if I put them together. So what I'll do is I'll run these together, quantity, and so we'll run our model like this. And I'll use log. I could have taken raw values, but log seems to be giving us good elasticity kind of output. So we'll use log of quantity. I could have used raw also. So for comparison, it does not matter much, but still let's use log, and log of budget phone. Budget phone. And this is our model one. Data is So this is our model 1. Now I'll not rewrite the code. Model 1, model 2 is nothing, but I'll just change here budget, social media. That's it. Now I'll put their comparative output with this Stargazer package. Stargazer. I have model 1 where I have telemarketing, telecalling budget. Model 2 where I have social media budget. Output I want to produce in the text form, header, and with the header as true. Header 2 will put that heading there. So let's compare the output. So first and foremost, see both the variables, they give me adjusted R square of approximately 7.7. So the explanatory power of this model with budget phone as dependent variable is higher with approx minor, you can see 7.7%, while it is 7.2%. So there's a minor increase. More importantly, if you look at the coefficient, the elasticity is 0.25%, which means 1% increase in telecalling budget leads to 0.25% increase in quantities. As compared to that, if there's a 1% increase in social media budget, there's a minor 24 difference. There's 24% increase in quantity. So the impact of budget phone is higher by approximately 1 percentage point for a given 1% point change in budgets. But whether it is statistically significant that 1% change is not, that we need to check, but still there's a 1 percentage point extra increase. So if you are spending incremental dollars on budget phone, you are getting a slightly higher bang for the buck. You're slightly getting a higher efficiency. But we need to further check. There are more statistical procedures where you check whether this incremental change is indeed significant or not. But individually, it is 25%, which is again statistically significant at 99%, while this result is also the 24%, 0.24%, that is also statistically significant. So they are very close. There's a difference of very small 0.01, you can say 0.01 percentage or 1 basis point difference between these two for a given 1% change. So to summarize, in this video, we compared the relative contribution or impact of spending on telecalling budget and social media budget on quantity demanded. We found that it is marginally higher for telecalling budget. We started the solar panel marketing case study implementation by setting the working directory, loading the relevant packages, and reading the data. Next, we did the exploratory data analysis. As part of this exercise, we explored and visualized variables including price distribution across territories, gender breakup of sales representatives, experience of sales representatives, professional background of sales representatives, distribution of advertising agency budget, comparison of budget across different channels, and finally, diversity of sales representatives across their native places. Next, we estimated the demand function using a linear regression with price, experience, degree, and marketing budget as independent variables and quantity demanded as dependent variable. We also computed the price and budget elasticity of demand. For the same, we made use of log-log type of regression modeling. Lastly, we also compared the relative impact of telecalling and social media marketing budget on quantity demanded.